Hello and welcome to item 6 of the first chapter of Effective Java, and this item is all about unnecessary objects. So item 6 mentions avoid creating unnecessary objects, and this probably happens all the time when you write a Java code, because Java has automatic memory management. Then some Java programmers who are maybe just at the beginning of their journey to become a great Java developer, they think that, okay, it doesn't have the problems of the basically manual memory management that we have to deal with when we write C++ code. So Java is great. We go and create as many objects as possible, and then we don't care about how they are going to be deallocated or distracted, right? So it is often appropriate to reuse a single object instead of creating a new functionally equivalent object each time it is needed. So if you have one object and that object has already some initialized state, and we can use it to accomplish some task, right? So if we want to redo that task again, or another task that can take advantage of this current object, there is no need for us to create a new object with the same state for that particular task. We can reuse this. Again, unlike C++, that sometimes the code would unnecessarily copy objects, which means it takes the entire state of the object and copy in the memory. In Java, we deal with references, and references are just glorified pointers, which means we are just copying. If you copy a reference, you're just copying a 64-bit long integer, which is very cheap, right? So copying references is cheap. So passing the references to different methods is also very cheap, because although it's passed by value always in Java, but then just a 64-bit integer just gets copied into the method stack, and that's just fine. That's very easy, right? So it's fine to pass objects around, pass references, and if we can reuse objects, we should. So we can also take advantage of the state of the object, right, as I mentioned. So an object can always be reused if it is immutable, and this is great, right? So if you have a class and you declare it as final, then or you don't allow the client of your code to actually change or mutate the state, maybe it's just you provide the API just has a constructor for the class, some getters, but there is no setter, right? Obviously, with the reflection API, you can always somehow access the private parts of your class and mutate them. But I mean, most of the time, the client of your code just cares about the public things, the public methods, the public part of the API, right? Because that's what is meant for the user or the client. So final classes are good. Immutable classes are very good, because then once they're created, you can always pass them around. You don't need to worry about them, and then you can use them, right? I mean, you can always reuse them. This item is all about reusing, and there is no point of creating multiple of them, because if it's immutable, then there is 100% guarantee that its state is not going to be changed by mistake. So it's always the same object, and we just pass it around by reference. And this is true especially for the strings. So whenever you're dealing with a string in your Java code, pay special attention to the fact that strings are immutable. So there is no need to create new strings. And how do we create new strings each time? We specifically call the constructor of the string. So whenever you use the new operator, so you say a string s is new, a string s Bob, this forces the JVM to allocate new memory to hold this string, and then point this reference to that memory. Now the thing here is that with this statement, what the JVM has to do, it has to create Bob first, because this is a string literal, so it's in the constant pool of your class file. So when Java C, the Java compiler, compiles your class, the Java code that has this particular line, this string literal is placed in the constant pool of your class file. And then when this operator new is called, obviously so the JVM has to allocate this in the Java heap, and then the new operator forces the JVM to create a new string, which is very bad, because you already created this string literal. What's the point of allocating an extra memory and then pointing this S to this, and then JVM also has to copy this string into the newly allocated memory space. So it's the work is it's not justified, right? So don't do this. I would say don't ever, or basically try as much as possible to avoid calling the constructor of the string or creating a strings bar invoking the new operator. Don't do this. Instead, use the string literal for assignment. Now the assignment operator is obviously overloaded for a string literals, right? And what happens here is that when the JVM sees this for the first time, it allocates this string literal Bob on the Java heap. And if you're familiar with the details of the Java heap, you know that there's a special part of the Java heap called a string pool, and this string literal is placed inside that string pool, right? And then this pointer is pointing to that string literal, so there is no duplication of memory allocation. Here the string literal is allocated, then a new memory space is allocated, and the content of this string literal is copied into that new memory, and then S is pointed to that new memory. But here Bob is allocated on the Java heap, and then S is directly pointing to the Bob, this string literal inside the string pool. Now if you execute this many times, what happens is that Bob is always allocated only once, and then all the different strings that you create, they are actually referring to the same exact object. With this new, it's not the case. I mean, in theory it's not the case, but obviously there are a lot of optimizations in the JVM, especially in the most recent version. As I mentioned, for this course I'm using JDK 15, so there are a lot of knobs that you can tune to make sure that such an inefficient code can never result in an inefficient runtime, right? You want to make sure that even if the code is inefficient at runtime, you want to make sure that JVM understands some optimizations, maybe the JIT compiler or whatever, they do optimizations. And that's the whole point of having a virtual machine, because then you want to make sure that at runtime there are a lot of knobs that you can tune so that you can get the most performance at runtime, right? So it is guaranteed that the object will be reused by any other code running in the same virtual machine that happens to contain the same string literal. So this is called string interning. So what I said is that when you assign a string literal to the string reference, what happens is that all this reference is pointing to the object in the string pool, and you're not reallocating the memory again. Now if you do this new operator, there is a way to actually make sure that this gets translated into the assignment with the string literal, and that's called a string interning. Again, if you're not familiar with this, what this happens is that intern is a native method inside, is a public native method inside the string API, a string class, and its implementation, obviously this is a native method, so its implementation is inside the C++ source code of the JVM itself. You can always download the source code of the JVM from GitHub. I believe they migrated to GitHub, and then look at the source code. But this is an intern, and then what happens is that this gives the JVM a hint that, hey, when I call this new operator, go ahead and try to intern this string, which means allocate this. When you allocate the string literal in the string string pool, just directly point this S to the string literal. I don't want you to reallocate memory. And again, even if you don't call the string intern in the recent version of the JVM, such optimizations should happen by default, or there are some JVM flags that you can tune at turn on or off at runtime. And we will look at one of them, which was added in the recent versions. Now the document for the intern says a string that has the same contents as this string, but is guaranteed to be from a pool of unique strings. So when you create this S and say s.intern, it returns a new string, right? It returns a reference to a string, but that string is definitely referencing basically a string literal in the string pool, right? It says it guarantees it is, but this whatever this intern returns is guaranteed to be from a pool of unique strings, right? And this is part of the Java language specification, right? You can often avoid creating unnecessary objects by using a static factory methods, and we already looked at this, and this was such an important concept that it was actually the first item in the effective Java. Try to favor a static factory methods, especially if you're trying to create immutable objects. By using a static factory method in preference to constructors on immutable classes that provide both the constructor and then factory methods, right? So if you are dealing with immutable classes, which is very good, again, because it's very safe to reuse immutable classes, try to provide a static factory methods, right? Or builders if you're more comfortable with builders. Now let's head to Eclipse and try to play with this string intern a little bit. So if I go back to my Eclipse workspace, I'm going to create new item 6, and then I'm going to create a class, let's call this test1. Let's have a main method here. What I want to do here is that now, as I mentioned, if we say a string S1, for example, new a string, and then say Bob. Now this create a string. If you look at the constructor, obviously this constructor has not been deprecated, which means it's part of the public API and you can use it. But it has the annotation for the hotspot intrinsic candidate. So this means that obviously there is an optimization can happen based on the intrinsics, the list of intrinsics that have been defined for hotspot, and one of them obviously about the string interning. So and then if I create a new string s2 new string, again we can just write it Bob. So and then we can do a sysout on s1 equals s2. So let's see what happens. This comes as false. What it means is that, so when it comes as false, it means that s1 and s2 are pointing to different objects or referencing different objects, right? When you say pointing, it means these are kind of pointers, but again, Java sugarcoats the concept of a pointer with references, but these are in theory on the back end of the JVM, which means inside the implementation, these are just pointers, right? So whenever you get a hold to a reference and you call a method for this object on this reference, behind the scenes JVM just gets a hold of the pointer that is pointing to that Java heap memory for this object, and then dereferences it and then calls that method from inside the JVM. So obviously one would expect this to return true, but this is false, which means these are referring to different memory areas in Java heap. And the other problem is that this is counterintuitive, especially if you're used to std string in, for example, C++ or just regular strings in Python or other languages, because any language that provides operator overloading, they would definitely overload this equal. So any language that provides operator overloading, they would always overload this equality operator, right? For example, in Python, if you create two strings, two different strings, this always returns true. Obviously in Java, if you want to compare content wise, so in terms of content wise comparison, we already know that the object class, which is the superclass of any class, provides the equals, right? S2, and this definitely returns true. Yes, which means the content, and this equals is case sensitive. So if the second one is a small letter Bob, this returns false. And we know that sometimes we need to disregard the case sensitivity when we compare a string. So obviously the string class already provides methods, for example, equals ignore case with another string s2, and this should return true. So we already know that, but again, item 6 is all about avoiding unnecessary objects or creation, avoiding the creation of unnecessary objects. And in this clear example, strings are always problematic, especially when you go the constructor route, which is not recommended. So how can we fix this? Maybe we can call the intern on these two, right? Let's see what happens if we compare the references, and let's go back to a case sensitive comparison. And this returns true now, which means now what we asked JVM to do when the first time it encountered this, it puts the Bob on the string pool, right? And then it creates when we call then it allocates memory for this string because we are calling the new operator, and then whatever this basically, let me break it down. So when JVM goes to execute this line, first of all, the Bob string literal, right? So a string literal. This is created on the string pool. And then when the new operator is called, what happens is that a new string is created, right? And the value Bob that was created on the string pool copied into it. And this returns let's say a reference to that newly created object. So this S1 is not pointing to the Bob, it's pointing to this new string object that has the value Bob. But then when we call the S1.intern on this, what happens is that this just makes S1 point to the Bob string literal, Bob string literal. And this newly created object is not used anymore, so it gets garbage collected. So that's how we're doing this. So behind the scenes, eventually we're creating an object, but then we immediately disregard it, right? Same for here, but then when this happens, when we call the intern on the second object, what happens is that it also points the S2 to that Bob in the string pool, and this object is garbage collected. So but then because both S1 and S2, because of the interning now, they all point to the same Bob, a string literal, then they are guaranteed to be pointing to the same object. That's why this returns true. Now obviously, instead of doing this, we can go ahead and write the Bob a string literal. This is the most this is the best way to do it. And this obviously guarantees that these two are pointing to them a string literal in the string pool, and the equality must return true. And JVM already knows that, right? Because these two are assigned to the same object. And know that again, there is a slight difference between new string, the constructor, and the string literal. But then I always advise you to use the string literal for assignment. Okay, now I'm going to create a public static method or public static void. Let's call this test1, and copy and paste this code inside the test1. And I'm going to create a new method. So public static void test2, and then obviously first we ran test1, and now we want to run test2. I'm going to comment test1. So in the test2, what I'm going to do is let's go back to new string. So let's bring back the constructors Bob, and then let's copy and paste it. And then what we're going to do is so let's run test2 to see everything works, right? The two S1 and S2, they are referring to different objects. But now JVM, in the recent version of JVM, they have added a VM argument. So in the VM arguments, if I go here and say hyphen XX plus use a string I believe deduplication. I believe they have added this, and I hope I typed it correctly. And this string comes, this still comes false, right? So let's run this again, which means that use a string deduplication. What it does, it relates to the garbage collection. So it doesn't really relate to, so this is the calling the constructor still allocates, and these two are still pointing. But then it says that um, uh, let's see what happens if we for example make the second one intern, and this still comes false. What if we make the first one intern and then call the constructor for the second one? This still comes false, and then obviously we saw that if we intern both of these, then this comes as true, the reference comparison. Now let's go back here, remove these interns, just run it quickly again, and then after this, before comparing them, I'm going to call system.gc. And then so system.gc, obviously we know that it's not a guarantee that the GC will run. It depends on the JVM implementation. I'm using the hotspot JVM from Oracle, and then basically I believe on the hotspot, at least in the latest version, it guarantees to run as far as I can tell. But see, even if we run GC, this reference comparison comes false, which is very interesting. So so what about we make the second one Bob? So we know that the Bob is already created and it resides on the string pool, and then the second one is so let's comment this string GC. Let's see what happens in this case. This still comes false, which means the second one is not pointing to that Bob. And then what about if we run GC? This is still false. So really the only way is to make this basically intern, and now it comes through. Another way, obviously, if an object provides a factory method, so always prefer factory method. So I can say a string dot value of char double float object. We can go with object and say Bob. The question is, are these the same then? And then yes. So as you can see, what happens here is that the value of is actually automatically does the interning for us. So again, to prove this, I'm going to basically bring back the constructor, new string, and then so this gives us false. But then if we use the value of method, it gives us true. And then if I go back here and then remove this flag, use a string deduplication and run it, it still works. So it has nothing to do with a string deduplication. It's just the fact that this value of just returns the object to a string. So calls it to a string on the object, and this has already been created on the constant pool. What if we say new string Bob on the first one, and then pass the string literal to the second one? This comes false now. But if we pass the value of method, then it comes true. Instead of doing this, if we call the constructor of the first one and then pass the reference from the first one to the second one to the value of, and then run this comes true. What if we, instead of passing the string literal, we pass the reference to of the first one to the second one? Now we expect this to come out as false, because again, new operator is allocating new memory. So always try to use value of, and the value of here has a very simple implementation. It just calls the to a string and returns a string. Remember, strings are immutable, so it just calls the to a string. And then JVM takes care of the fact that if you call the to a string on a string literal, it just returns a reference to that string literal on the string pool. And again, I'm putting emphasis of the string on the strings because these are strings are the most commonly used objects, string literals or strings in general. But there are also other types of objects that we have to be careful about, and those are the primitive types. And the fact that auto boxing and unboxing happens behind the scenes. So sometimes we don't see that, and we think that we're working with primitives. But obviously, for example, Java collection API doesn't support primitives at this point. We don't have any specialized collections. So everything is objects, and then the Java compiler has to auto-box those primitives into objects, the wrappers, and that can cause significant overhead on if you're doing computation, for example. So know that the constructor must create a new object each time it's called, or it's actually the new operator, right? Each time you call the new operator, it just asks the JVM to allocate new memory. So some object creations are much more expensive than others. If you're going to need such an expensive object repeatedly, it may be advised to cache it for reuse. And obviously the very example that everybody mentions when they teach this kind of caching concept is the wrapper classes for primitive types in Java. They all provide this static factory method value of. For example, the integer wrapper class, it can cache certain amount of range. For example, the default is from -128 to 127, I believe. There is a flag in JVM. At runtime, you can change the maximum number for caching. I believe you cannot change the minimum value, which is always -128. So the factory of in wrapper classes, they always, as I mentioned, the integer class in JDK, when you call the value of method, it caches. They implement caching, for example, Boolean, integer, etc. Caching can be done via public, private, static, final fields in an object. So you make them a static final, or if you want to do lazy initialization, you don't make them final. We can use lazy initialization to avoid unnecessary creation if no one is using it. However, be careful about multi-threading, which means basically the question is which thread first initializes the static field, which is the cached value, right? And what happens if two threads want to read the cached value at the same time? So one of them probably reads null because it's not initialized. The other one reads the initialized value. So there could be some race condition there. When an object is immutable, it is obvious it can be reused safely, as we mentioned that. So immutability is good in terms of avoiding unnecessary creation of object. Another way to create unnecessary object is auto-boxing. As I mentioned, if you're doing any computation, numerical computation with Java, you have to be very, very careful about primitives and object. Or the boxed value, boxed representation of the primitives. You have to be very careful about it. Auto-boxing blurs but does not erase the distinction between primitive and boxed primitive types. Again, the book also cautions us about this kind of auto-boxing, and the problem is that it happens behind the scenes, so they kind of blurred it out so you don't feel it, but it can happen. It can be in your code, and then you end up with a severe performance penalty. So let's head to Eclipse. So I'm going to create a new method, public static void test3, right? And what I'm going to do in test3, basically we discussed that value of method, and the caching. And in order to demonstrate the caching, what I'm going to do is say var, or it's basically an integer, right? From Java lang, let's call it I1 is a new integer. And by the way, all these constructors, as you can see, for the wrapper classes are deprecated, unlike the constructor of the string. That is not deprecated. The constructor of all these wrapper classes, integer, float, bool, whatever, they are all deprecated, which means it's not recommended to use the constructor directly. So what we're going to do, so I'm going to use it anyway, like 21. So integer I2 is 21, and then again sysout I1 equals I2. So I'm comparing the references, and let's see what happens. This comes as false, which is not surprising, which means these two objects are not equal. Now notice what happens if I say, obviously if we use literals, I mean obviously we expect these to be the same. So let's see what happens. and this comes true, there is no surprise. But then if I instead of 21 I say 210, what happens then? This comes at false. So why is it that we're using integer literals? 21 it comes as true, and then 210 it comes as false, because behind the scenes some caching happens. So if you look at the bytecode of your class file, you see that here this gets translated to a call to integer value of. So integer dot value of. It doesn't call the constructor, it calls the value of. Why? Because value of for the integer class has some caching, and that caching goes by default, I believe, from so caching range is from 100 minus 28 to plus 127, I believe. So we can test this. 128 minus 128, let's see if this returns true. Yes. Minus 129, what about this? This returns false, right? So the minimum is 128. What about the maximum? 127. 127. Let's run this. True. What about 128? 128 false. So the maximum is 127. Again, as I mentioned, there is a JVM flag, and runtime you probably can adjust the maximum value for caching. But then if you go back to the constructor, all these deprecated ones, they just assign the value, they don't do anything with it, right? But then if you look at the value of method, which takes a let's see, value of a string, where is the let's see, so to a string, to octave, to a string, parse value of a string, value of int. And as you can see, it still calls the constructor, but then if it searches the cache, integer cache low high, and then if it's in the cache it just returns it. Otherwise it just goes ahead and creates a new constructor. And obviously in the future they make the constructor private, so that right now it's deprecated but it's still public, right? But then at some point they make it private. And then we have the max value and mean value. These are hex, and you can assume, you can kind of see what these are. These are the mean value of the integer. And then there should be somewhere a string, the integer cache. So the low value is minus 128. It's hard coded. The high value, it depends, again, the JVM flag. So high value may be configured by property, which means you pass a JVM flag. So the default is 127, and when the JVM loads this class into memory, this is part of the static initializer, so it defaults to 127. And then it just goes ahead and basically initialize from archive or whatever. So, and then if it's not initialized and the flag is set, it just goes ahead and creates the cache based on whatever high value is set in the JVM flags, right? So this was an introduction. Again, this happens for all the primitive types. Even the Boolean also has this, but always remember that when you use a string literals and assign them to wrapper classes, to get a box value, it translates into a call to the value of method, not the constructor, because the constructor at the moment doesn't do any caching. It just directly assigns the value to the internal value that this object holds. But the value of checks for caching. If the value is this integer literal is within the cache range, then you can basically it just goes ahead and returns the object that is in the cache. And again, caching is a great concept because especially for if the objects are immutable. So if objects are immutable and it makes sense to cache part of some of the objects that you create as part of your API, it's better to cache them. Always try to do this. Okay, so to summarize item 6, which was again about unnecessary objects, and we always should try to avoid creating unnecessary objects. The book emphasizes that prefer primitives to boxed primitives and watch out for unintentional auto boxing. And again, this is very important if you're doing any numerical calculation. avoid using list of double, for example, because there's definitely auto-boxing happens. Don't use collection, any type of collection when you're trying to just focus on numerical calculation and you have a lot of primitive types that you need to hold. Always use a double array or int array. The good thing about Java is that it provides primitive values, right? It has primitive values, so not everything is object. A double array is an object, but it can access memory, save values directly as primitive and has access to that. And if you are familiar with any numerical implementation methods, or basically if you've done any implementation for numerical or scientific computation, you realize that cache misses are very, very important. If you have a list of double, each one you want to read a ref value, it has to load that ref, because list of double, it's a list of reference or a list of pointers, right? So you have to go to that pointer, read the value of that pointer, and then dereference it and jump to another place in the memory. So indirection causes a lot of cache misses, right? Now obviously in the recent versions of the JVM they're trying to minimize this, but anytime you need to read a lot of primitive data from memory, you have to rely heavily on cache lines, otherwise your program is going to be very slow. So cache misses are very important for scientific computing. So definitely always watch out for unintentional outboxing when you're working with Java and trying to do numerical computation. So creating and reclaiming of small objects. So this is like on the contrary side, creating and reclaiming small objects whose constructors do little explicit work is cheap. So it's not like we say that never create unnecessary objects or never create duplicate objects. I mean, if the object is small and the constructor doesn't do much, then it's fine. Allocation in Java is relatively fast. The GC, the garbage collector, always tries to compact the Java heap. So it's not like it's relatively efficient anyways, right? But it's not the best practice to rely on JVM to make sure that the garbage collector always maintains a clean Java heap, everything is compacted, etc. So there is some part of the responsibility that is on the shoulder of the developer, right? The developer has to work with JVM for the best performance. So creating additional objects to enhance the clarity, simplicity, or power of a program, the power of your API, is generally a good thing, right? So we're not saying that don't create additional objects that basically makes the life of the end user or the client of your code easier. Yeah, you should definitely do that. I mentioned that this flag for JVM use string deduplication has been added in the recent versions, and that's more or less a hint to the G1 GC. So I don't know if this flag works with the ZGC, but from JDK 15 I always default to ZGC. But if you're using G1 GC, you can also give this a try. Use a string deduplication. So this is kind of like a least effort attempt to eliminate duplicate strings, which is pass this flag to JVM if you're working with G1 GC. When you pass this JVM argument during application startup, JVM will try to eliminate duplicate strings as part of the garbage collection process. So this kind of happens during the startup of your application. During the garbage collection process, the JVM inspects all the objects in the memory. Thus, as part of that process, it tries to identify duplicate strings among them and tries to eliminate it. And again, strings are a big part of most Java applications, because if you are reading from a file, text file, etc., it's always like reading strings and working with strings. That's why JVM has tried to focus on string optimization as much as possible. So I hope you enjoyed this item. Please stay tuned and I'll see you in the next one.